Hi, Stefan.
Hey, Robert. Good to be here.
Welcome to the ZEISS Innovation Talks, where we bring you, our experts, to talk about the latest innovation in industrial quality solutions. Today, we talk about microscopy, and I'm happy that Stefan is joining me to cover this topic. So, Stefan, do you want to say a few words about yourself and your history at ZEISS?
Yeah, sure. My name is Stefan Knopf, and I just celebrated my 10th anniversary
Congratulations.
here at ZEISS Microscopy, and currently I'm in the position of being responsible for industry microscopes in Europe.
All Europe?
All Europe.
Okay, that's a busy travel schedule, I guess.
Correct.
So now we know a little bit about you, but let's give the audience the chance to get to know you a little bit better. So I prepared a little lightning round, if you don't mind, with 2 personal and 2 technical questions.
Okay, go ahead.
If you have to choose, would you go, and I ask for a short and spontaneous answer, would you go for Netflix or YouTube?
Netflix.
Okay, then maybe we'll bring you to YouTube later and you will change your mind. Something I don't really know about you, singing or dancing?
More for singing, I would say.
Okay, we will try this out later. And now we go to the technical person. If you have to choose optical microscopy or electron microscopy, where's your heart?
I mean, my heart would be for optical microscopes, yeah, because that's where I started from, yeah.
Okay, thanks for sharing. And now, if it couldn't be a microscope, what technology would you choose? X-ray or tactile coordinate measurement systems?
I would go for X-ray because this is also about material science like microscopes, and therefore it's a bit connected, and
okay,
that would be my answer.
And that's already a good pivot into what we are going to talk about today. So we want to talk about the key application of what is microscopy all about, then key trends from industry that you see, and of course, how we respond at ZEISS with our innovations. Yeah. So let's get right into this. ZEISS is doing microscopes for 170 plus years. So people know it, but what is it all about in industrial settings?
Let's maybe start one step prior to this question and answer. It's about, microscopes. When people usually think about microscopes, they think about vaccine research for the COVID pandemic, for example, a couple of years ago. They think about analysis, blood analysis, universities, about a different life science application, and usually not about industry. And because we are somehow, industrial microscopes, we are somehow hidden in the industry, so not really visible, but very essential for the whole process. That means looking at the industry, we have either the R&D departments, where you develop new materials, new composites, maybe new production processes. On the other hand, you have the quality assurance for the production itself. So whenever you produce a part, you have to be sure that this has good quality for your suppliers or customers.
And what kind of microscopes are used in this material development or in the quality control? So what are our customers using to realize
Actually,
this?
they're using a lot of different microscopes. So we start, as you said, with optical microscopes, with stereo microscopes, with upright microscopes. There are different possibilities for this one. Then we have electron microscopes, starting from conventional electron microscopes until they call them cross beams or focused ion beam electron microscope. Also X-ray microscopes. There are a lot of different ones
and can you
that are used.
Explain a little bit the difficulties or the differences. When would I use a light microscope? When do I use an electron microscope? And what does X-ray microscopy bring to the table?
Usually the process would be that you start from a macroscopical view. So first of all, you need to see
overview.
What is the overview from your part, a small part, a big part, a connector, whatever it is. This is done with optical microscopes, maybe in the production, but maybe also in the laboratory itself. And then if you need more resolution, you come to the upright microscopes, the optical ones, but then also to the electron microscopes to detect the chemical composition, for example, of a crack somewhere in whatever part it is. And then for sure also about X-ray microscopes connected to the computer tomographs that we also have in our portfolio, and where you can look inside the material.
So this is then non-destructively looking into the microstructure internally of components.
Correct.
Or
Absolutely.
defects. Yeah.
Correct.
Okay, so if I understand correctly, it's about application-wise optical inspection, it's about failure analysis, what else can you do application-wise with those technologies?
Application-wise, a very famous one where we also put a lot of effort in, this would be technical cleanliness.
Okay.
And technical cleanliness can be done either with light microscopes, where you can detect shiny particles, so metal particles, or also fibers and also other composites, for example. The whole process would be like this, that you produce a part, whatever it is, metal part, for example,
So it
small
could be in automotive, could be in medical, could be in electronics.
Could be in either industry, yes.
Okay.
It's coming from the automotive industry because several years ago there were some failures when it's about moving parts and you have some particles in, they get stuck, they get scratched, and they have a failure.
And this
and
is
therefore
not
they
good for the
introduced
reliability. Okay.
Correct. And they introduced certain standards for that.
Okay.
But these kind of standards, they are now also transformed into medical industry, but also into aerospace.
So it's broadly used. So and it's about finding particles and characterizing them. So how does this workflow
At the end, everybody in industry believes that their parts are clean, but in fact they are not.
They're not?
You always have contaminants everywhere. The question is just if they hurt your usability of the part itself or not.
And I guess they are so small that you can't see them. It's not obvious that the particles
You
are
cannot
there.
see them on the surface.
Okay, and this is
they
why you
appear
need
to be clean. And what you are doing is actually you take your part, you wash them off with a special liquid. You take this liquid, press it through a filter,
Okay.
and then you scan the filter starting with a light microscope, as I said in the beginning, about seeing if it's a fiber, if it's a plastic particle, or if
Okay.
it's a metal particle. But furthermore, if you want to know what kind of particle it is, you take this same filter, put it to an electron microscope, scan it again, and you have the results about the chemical
And
composition.
microscopic particle always means micron-size particles. So, or how small can we detect those particles? What is a critical particle? After
Critical
all?
particle in automotive industry would be about 50 micrometer would be the starting point.
Okay.
But nevertheless, depending on the industry, in
It's like a
medical,
human hair,
could
basically.
be like a
So-
human hair.
Okay.
That's correct. So
And
very
even smaller.
tiny already. But even in medical applications, it could be even more critical when the parts are even smaller. So you have to scan it. You can scan it with a light microscope again and with an electron microscope.
Okay, and so then we have optical inspection, we have the failure analysis, technical cleanliness. You mentioned the materials. How is microscopy helping to assure quality or incoming goods inspection of materials?
One prominent example would be we have a customer from Ireland, from the UK, called Smith & Nephew, and they have a factory in Switzerland where they produce hip implants. And for these hip implants, it is very important that there is a surface coating on it with a special thickness in order to be absorbed by the body after the implant. And
So
that
how do
means
they
you
inspect this,
have, they did it all manual
Okay.
over years and years, and it took about an hour for every part, fully manual. And nowadays you can also do it with an automated microscope, so with a microscope with a moving table, with a special fixture on it,
Okay.
so that you are, first of all, with the acquisition of the picture pretty fast, but the next step would be that you analyze this picture in a very easy and fast way with artificial intelligence, for example.
So this all sounds a lot like digital workflows based on software. So we have a software that connects all the automation, image acquisition. You said analysis is automated and report. So everything in one software, or?
Everything's in one software. There is our software called ZenCore. It's basically a software environment for all our different microscopes that we have. So light, electron, and X-ray microscopes.
So it
to
even goes
combine-
beyond
even
just
goes
a single technology.
Yes, correct.
Okay.
It's important because we have a big portfolio and we have to match all the different needs of our customers to combine the results in one cloud solution to have the results in.
So this means you can get into one report results from different technologies, really adding to the understanding of your workflow or your analysis.
Correct.
Okay.
And as an example from the past, when you go back 40 years, you would have no computer connection. You have just a fully manual overview from manual microscopes, and you simply depend on the user experience, and you have to believe what she sees on the part. Over the years, we developed different softwares, but not really with a workflow like we have it nowadays, and also about the reporting. Furthermore, you can also connect the microscopy images into the metrology world.
Okay, how do we do
So
this?
there is a reporting format called PyWeb from the metrology side of the view, looking about statistics and looking about numbers, and we can match them with our images.
So you can
together
do
into
trend
one cloud.
analysis of microscopy analysis as well?
Correct.
Okay, that's impressive. So if I understand you correctly, imaging, analysis, reporting, fully automated, but can I even do copy and paste to other locations? Because we have a lot of global customers who have to do the same thing in different plants.
True.
How
This
is
is
this enabled?
the important background of this is actually that you can combine different sides of the world together. So as you just said, I mean, looking at the big key accounts that we have, doesn't matter if it's aerospace or medical or automotive
They have
industry.
to follow their
They have
standards.
to follow their standards all over the world. Doesn't matter if it's in Mexico, if it's in Singapore, if it's in Ireland. You have to control your quality in the same way everywhere.
Okay, and that's like done in a metrology measuring plan. We now have a microscopy inspection plan, or how can I imagine this?
You have workflows that you can define. So it's either user-dependent workflows, where it's still a user needs to decide if it's good or bad. On the other hand, you can also do that with artificial intelligence, for example, machine learning, to have a fully automated reporting at the end.
So where we take the knowledge of our customers to train an AI model and plug it into our software, or do the customers do this on their own?
They can do that on their own, but for sure we support them. We have an own division about this, about software solutions to support our customers with this request. And yes, but the customers can also do it by themselves.
Yeah, and if I understand correctly, this really speeds up quality control workflows where you have to do the same thing over and over again in a standardized way, and you can really, get the human out of the loop. And
I mean,
automate.
it can be a very, very easy mathematical operation. I mean, when you have 100 parts to check and you need 1 hour per part, you have
that's
100
a
hours.
whole week, 2 weeks.
And whenever you can accelerate this, you can either save employees, but you can also save user-dependent resulting and do it fully automated. And this is helping to guarantee your process and the whole quality assurance of your part.
Great. And as you told us, very relevant for those regulated industries where it's mandatory to do those inspections. You promised at the beginning that we also have some innovations to talk about when it comes to optical inspection, and you already mentioned that this is usually starting at the shop floor where people have to check the basic quality of what they manufacture. If it's an electronics or a medical device or a turbine blade, whatever, you have to look for scratches and defects. So what is the innovation that we bring to those kind of customers and to this application of optical inspection?
Let's maybe use the electronics industry. So whenever you have a PCB board, you have some soldering, some pins on the PCB board, and you would like to check in the shop floor if the pins are correct, if the soldering is correctly done,
so nothing
and so
is
on.
bent or
Nothing is bent,
okay.
correct. This is usually done by either stereo microscopes or different other types of magnification lenses,
this means
whatever.
looking through the oculars and
Correct.
bending
This,
down.
And our new so-called entry-level digital microscope is supporting you in avoiding these fatigue moments in the production, because at the end, when you watch 8 hours through eyepieces, it can be very, very hard.
So how do we do it now?
And this is now, it's being done right now. But with our digital microscope, you just have a screen. You don't have eyepieces. That means you just watch to a screen. It's better for your body feeling in front of the microscope, and it's much more healthy and it's much faster. And this is and much easier. Maybe
But of
that's
course,
the
this
right
means
wording.
it's all about digitization, and you simply look at a computer screen. What about this? Usually, sometimes feel not in the same brilliance. So if I look at my 20-year-old TV at home, I go to the shop and see 4K. It's a different world. So where do we stand in the resolution? Is it a real life crisp image that we provide, or is it still?
Yes, for sure. I mean, you just said it, 4K resolution. So this is what we implemented in this system.
So that's really.
We have a camera with 4K resolution, but also with 60 frames per second.
So what does 60 frames?
That means that the movement of the part, so when you want to do a very fast optical inspection, is not kind of struggling to see on the screen. Furthermore, you have a very big working distance, which is also very important, so that you have some space
So
below
really
the
space
microscope
on the table to operate.
You can use large parts, not just limited to small ones. And furthermore, there is a 25x zoom integrated. That means you don't need to exchange the optics.
So like a digital camera on steroids, really giving you a lot of zoom and resolution.
That's a good explanation, yeah, exactly.
Okay.
I mean, you have a macroscopical view of your part, and then you can also zoom in without changing anything, and you are in a microscopical world.
Okay. And how difficult is it to use, set up, and explain to our customers?
Actually, there is not so much to explain. I mean, there is a stand. The stand has already the computer integrated. It means you just plug in the microscope itself, connect the monitor, and at the end you have a picture, and then it's about zooming in and out, and that's it. So there is not so much to learn. There's no training necessary. It couldn't be any easier.
This sounds as easy as it could get. So how do you do the demonstrations? Just put it at the customer and let them work with it, or?
Yeah, usually coming from some other system, you took some time. About demonstration, this one is being demonstrated within seconds, maybe minutes, and that's actually it.
So I'm intrigued. Thanks for sharing those insights, and I guess it doesn't get any easier from here. Before we close the session, do you want to give some closing remarks to our audience, summarizing what we've talked about?
Yeah, so maybe summarizing would be into 3 points about how to say, we have a big portfolio. We have different technologies at hand, like the light, the electron, and the X-ray microscopes. The second point is we could combine all of these with one software solution, which is called ZenCore. And furthermore, at the end, with this new digital microscope, we make it as easy as possible. That means at the end, it should be easy for the industry to cover the challenges of our customers.
Great, Stefan. Thanks for sharing. And thanks to the audience for listening. This was the ZEISS Innovation Talks on microscopy. And I hope you stay curious, keep innovating, and see you next time.